The next topic is the rusting of iron. Basically, what is a rust? Rust is actually hydrated iron 3 oxide. So hydrated iron oxide is called rust. Like when we say Fe2O3 dot 3H2O, means iron oxide which trapped some water molecules. Iron oxide is an ionic compound. And what is the structure of the ionic compound? In ionic compound, we have a lattice. Lattice means the regular arrangement of the particle. And the ionic compound have a lattice of positive and negative charges. So regular arrangement of the particle, we call that as ionic compound, or regular arrangement of the ions, here iron oxide. But what is the term hydrated means? The term hydrated means it traps some water molecules. So there are some water molecules trapped. That's why we call that substance as hydrated compound or hydrated substance. And these water molecules which are attached, they are known as water of crystallization. So some of the compounds have a tendency to trap the water molecules when they form a lattice, so they trap water molecule. And how this water molecule can be removed? If we supply the heat energy, so these water molecules escape and it will become anhydrous substance. So if you want to, what is the appearance of a rust? Rust is red brown. So if you want to plan an experiment, to show both oxygen and water needed for rusting of iron. So we need both water and oxygen for rusting to occur. So if we have 4 test tubes or 4 beakers or 4 measuring cylinders equal size, the first is filled with boiled water. The second one is filled with dry air. The third one is filled with moist air. And the fourth one, example, it is filled with oil. So we take equal size of iron nails, equal size and equal masses of iron nails in these containers, and there's a lid. So this one is filled with a boiled water. Boiled water, when we boil the water, actually we remove the air from it, so it does not contain air. Here we have a dry air, moist air, and then the last one is inside the oil. So the first one, and we leave this apparatus for 1 week or 15 days because rusting is a slow process. So it will take time. It will take time for the formation of the rust. So the first one is a boiled water. So boiled water means it contained water. Water is there, but oxygen is not there, because when we boil the water, we remove the dissolved air, so there is no oxygen in a boiled water. Here we have a dry air, there is no moisture in it, so there is no water, but oxygen is there. This one is a moist air, so it means it contains water because there's the moisture, and because it's air, so air contains oxygen as an active component. This is oil, so means there is no water inside. Water vapors are not there, and oil does not have dissolved oxygen, so there is no oil as well. So if you leave this apparatus for 15 days, which will rust after 15 days?
The moist one.
The moist air. Yeah.
The container which is filled with the moist air, that will rust after 15 days. But what will happen to the mass of the iron nail? Will it will increase or decrease after 15 days?
It will decrease.
So mass of nail after 15 days, because when this iron oxide is formed, so the mass, because it is taking oxygen and water from the surrounding, from the atmosphere, so the mass of a substance, the mass of iron nail will increase. So this experiment shows for rusting, both oxygen and water are essential. Even one of them is not there, the rusting will, the mass will not reduce, the mass will increase. If the layer of the rust, actually what happened, like why the strength of the material decreases?
Because it corrodes.
Yeah, because it corrodes. So what happened, like if this is a piece of iron, this is a piece of iron, so what happened, this iron reacted with, here I mentioned the mass of the nail, I did not say mass of iron increases, I'm saying mass of nail increases. Why? Because it reacted with oxygen and water vapor in the atmosphere. So when it reacts with oxygen and water vapor at that from the atmosphere, so it will form a layer at the top. And as the layer is formed at the top, because oxygen and water are absorbed or taken or reacted, so the mass will increase. But what happened, why the strength reduces? Because when the layer of the rust is formed, if you touch a piece of iron which rusted, so if you touch this layer of rust, it tear off, means it removed from the surface. So when it removed from the surface, now the inner surface is exposed, then the inner surface will also rust, then the rust layer will tear off or remove, and that's why when a rusting of iron occur, with the passage of the time, as a layer of the rust with the passage of the time, as a layer of the rust is removed or tear off, the strength of iron decreases because the size of iron or amount of iron decreases. So when rusting occurs, the formation of a rust increases the mass. But as the layer is removed from the surface, so the mass, the strength of the iron reduces as it contains less number of iron particles. So how we can prevent rusting? So there are different ways to prevent rusting. Actually, water and oxygen are not removing that layer. Just a minute, discussion I will answer, and then how to prevent rusting. So what happened, look, if you have a piece of iron, so this is the red part is representing iron. The oxygen and the water vapor reacted with iron, and it will form rust. So this blue shade is representing a layer of a rust. But this layer of a rust, it's not strong, so it cannot remain in contact with a piece of iron for a longer time. So this layer of the rust cannot remain for a longer period of a time. So what happened, this layer scratch or remove from the surface, because this layer is iron oxide. So as this layer is removed from the surface, you are left with small amount of iron. As the thickness of iron or amount of iron decreases, the strength of the object will also decrease. So layer of this rust on the surface of iron cannot remain in contact for a longer period of a time. So it is removed or teared from the surface, which result in reduction of the strength of iron. So if we want to prevent the rusting of iron, what we should do, we should cover the surface so we can paint, we can grease, oil or grease, we can electroplate, or we can use sacrificial protection. So these are few methods which can prevent. So normally, if we want to paint, normally it's used for the large structure, such as bridges, so we can use a large structures. If we want to prevent rusting of a moving object, like example inside the car engine, there are moving parts and we want to prevent rusting, so we use oil or grease. Electroplating or galvanizing, both are used for small structures. I will explain each. And sacrificial protection It's a similar. It can be used for pipes, underground pipes. So what happened, how a paint will reduce or prevent the iron from rusting. So example, you have a door which is made up of iron, and if it's pure iron, it will definitely rust. So you want to prevent this door or grill, you want to prevent it, that it should not rust. So what we do, we paint this. So when we paint, basically what painting will do, the painting will not allow the structure to interact with oxygen or water vapors, because both oxygen and water vapor will cause the rusting. Yeah, once this session will finish, I'll share a next session link with you. So both water and oxygen are not able to react or come in contact with a piece of iron. So that's how the paint is reducing the effect or preventing the iron from rusting. Same thing in the machines, when you have a moving parts. So what you can do for these moving parts, you cannot paint the moving part. Why? You